Hi everyone, so my name is Zach Vines, and what we're looking at today is how to calculate a chi-squared value whenever dealing with a univariate chi-squared test. So first I want to distinguish between two of some of the major types of chi-squared tests when you're first getting involved with this in statistics, is that we have univariate, which is what we're talking about here, where we just have one column of numerical data. So I distinguish that between a bivariate chi-squared test, where we have more than one column of numerical data. We have another video that goes through some bivariate examples, and you might also see those being involved with crosstabs or contingency tables, where basically we have multiple dimensions of data that can be compiled through into cells, almost like an Excel spreadsheet, and you can analyze how those characteristics cross over. But what we're talking about here is literally we just have one column of numerical data that represents something, and we analyze that, and we try and find a chi-squared value in stats from that univariate test. And so in general, the chi-squared value is just going to be this formula right here, where it's the sum of, so that big kind of backwards E, that sigma right there, represents that you do this formula for every single observation you have, where you take your observed frequency, so what actually happened in the sample, so OF is observed frequency, so you go into the wild, you do your sample, you find some information, what you actually found is what you observed, and thus you plug in for OF. EF is what you would expect to happen. It's your expected frequency, and that's totally based around what the problem's actually asking about, what it is we're hypothesizing about. We'll get into two examples here in just a moment that kind of distinguish two major categories of univariate tests as far as how do you find that expected frequency. I think that's probably the trickiest part when you're first learning this. And so that's actually the formula right there. You just do that formula for every single observation, you're good to go. Finally, for the hypothesis setup for this, if you do eventually want to accept or reject a hypothesis, setting this up, kind of goes hand in hand with the expected, so it is important to know that. It's case by case because the way you find the expected frequency is totally based around what is the context of the problem, what is it that we're trying to find out. But the general rule is that you want to match it to the expected frequency. So that might be kind of weird to say in a theoretical sense at a high level, but I think the important parts are recognizing when you're dealing with a bivariate test, so you have one column of numerical data, what the formula for chi-squared is, and let's just go ahead and segue into two examples to sort of make things a little bit clearer about that. Okay, so for this problem, you can see that we have basically a running tally of different brands of consoles, or in this case, we have a PC involved as well. But we have a PlayStation 4, an Xbox, a Nintendo Switch, and a PC. And what we're wondering about is whether or not there tends to be some sort of preference among the systems, whether in general it seems to be a pretty even split between all the systems, if perhaps in general one brand tends to dominate for this particular generation of console, maybe people prefer the PlayStation over the Xbox, or people just want to stick with the PC, whatever the case may be. But what we're wondering about specifically is there a preference among the systems? So first of all, to set up the null and alternative hypothesis, it's what we're wondering about right here. And like I said before, it goes hand in hand with your expected frequencies. But let's actually talk about the hypotheses first and connect that to the expected frequencies, and you'll see how nice they go hand in hand. But if I'm wondering if there's a preference among the systems, simply I'm going to say for my null hypothesis that they are equally likely, and for my null that they are not equally likely. So just kind of shorthand, meaning the same thing as above right there. So if that's the case, then let me just continue with my problem, because again, the point is just for me to fill out this chi-squared value, which is just your observed frequency minus your expected frequency squared divided by your expected frequency for every single item. So let's see what's going on. So we have that information given to us in the very beginning, the brands along with how many people in our sample said they preferred one console or one brand versus another brand. So it looks like 32 people preferred PS4, 28 preferred Xbox, only 15 preferred Switch, or 25 preferred PC. Okay, so that's what actually happened when we went and did our sample. So that's what we observed. So it's our observed frequency. So I kind of segue the information they give us right there into this nice chart that really helps us cleanly plug into this formula right here. You don't have to do this chart. You could just kind of individually recognize what the observed and expected is for each one and just plug it in. But the chart just kind of keeps everything nice and clean, so I'd recommend that when you're starting off. But your observed frequencies is simply what you're given. Your expected frequency directly ties into what we're wondering about with the problem and what the hypothesis setup is. Well, here's what it's saying. We're wondering whether or not the system preferences are equally likely. Well, first of all, given our observed frequencies right here, we have a total of 100 people we sampled, because we have 32 from PS4, 28 from Xbox, so on and so forth. When you add all of them together, that was 100 people that we asked what their console preference was. So if I'm wondering what would the expected frequency be if they were all equally likely, then I would think, okay, well, if I have 100 people that I sampled, and let's say that there wasn't a preference at all, it was just split right across, everyone preferred the same amount, then I have 100 people, I have 4 different brands to choose from, so 100 divided by 4 would just be 25 people each. So you can see under this situation, it would be equally likely that they would prefer one console over the other. So when I say that the expected frequency and that hypothesis setup is case by case, I really just mean look at what the problem says and connect that to the number of trials in your sample, in this case the number of people we asked, what was your console preference, and then kind of translate that into what the expected frequencies would be. So in this case we said 100 people, 4 brands. If it was evenly spread throughout, there was no preference, it would be 25 for every single person. So from that point, we're just going to plug directly into the formula. So I need to find my OF minus my EF. So let me just do a column specifically for that. So I take my OF minus my EF, and I get 7. Then 28 minus 25 is 3, so on and so forth. And I get all of these OF minus EFs. One thing that's really important is that you should add all these up to 0, and that's your check figure. If you add up all of your OF minus EFs and it doesn't equal 0, something went wrong right there, so just make sure you double check that. But the check figure checks out, so we're going to continue moving on. So at this point, I'm wanting to find my OF minus EF squared. So I take my OF minus EF I just found, so this is the numerator. I'm going to square each of them. So I get 7 times 7 is 49, 3 times 3 is 9, so on. And I have my overall numerator. I really have my OF minus EF squared for every single observation. For the PS4, Xbox, Switch, and PC, I have each of those numerators. So here's the thing. We could do it the long way. That is probably the most careful way to do it. The shortcut I'm going to show you only really applies for this problem. The one we get into next, you're going to see you can't do the same thing. So here's what we do for this, pretty much every single problem it'll work out this way, is that for each observation, so this sum of right here means that for each of these, take your OF minus EF squared and divide by its respective EF. So you can see for the PS4 observation, we have 49, and I'm going to divide that by its EF 25. So I get that number right there. And then I add to that, because it's the sum of 9, this OF minus EF squared divided by its EF. And I add all those together to get 6.32. But notice, in this case, because what we're wondering about is whether or not they're equally likely, we have a common denominator here. So for every single observation, we're dividing it by 25. So really what you can do is just add together everything for the numerator, so every OF minus EF squared, you can come into this final number right here, so you can see the star kind of connects the two, and just do overall 149 divided by 25, because the way that works, the math works out to where if you have a common denominator, just divide the sum of all the numerators by that common denominator, and you get the exact same thing. So that's how you find the chi-squared for this particular problem. The next one we go into, the EFs aren't going to be as straightforward. It makes sense that, if it's equally likely, we have 100 people, 4 brands, divide the 100 people between the 4 brands, and thus get 25 each. This one's going to be a little bit trickier, but you're going to see it's the exact same principles at play, so let's go through that right now. Okay, so now we're getting to a different problem, and you're going to see kind of right off the bat we have a lot more information that has to be given to us right here in order for us to be able to solve for the expected frequencies, which I would say is probably the part that requires the most judgment. Everything else is just kind of plugging and playing into the formula. But let's kind of analyze the context of the problem and wrap our head around it. So to start with, we have these regions right here. So kind of what's going on is we have a TV show, and we're wondering whether or not the viewership of the show tends to match just the overall population distribution of the US. So we have people from north, south, east, and west, and they all tune into the show. And we're wondering if maybe some regions tend to watch it more than others, or whether or not it tends to be, generally speaking, the US as a whole watches it. And so what happens is that in the first series of information, we have the different regions and how many people viewed it. So we'll assume those are in thousands, so it's 250,000, 300,000, but just to make the numbers a little bit cleaner later on, we'll say 250, 300, 100, and 350. Those are the number of people, kind of as per the ratings and everything, that tuned into this TV show. And so what they give us is the actual population distribution of the United States. So they give us the fact that of the entire population of the US, 26.1% of people live in the north, 32% of people live in the south, 13.9% live in the east, 28% live in the west. So what we're wondering is, does the viewership of this show match the US population distribution? Or another way you could word that is there some sort of preference among the regions who watch the show? Kind of wondering whether or not it's kind of localized to a particular region who likes the show, or perhaps is it pretty much across the board seems to be fairly one-to-one. People in general in the US watch the show. So the null hypothesis would be just that the viewership matches the population distribution, and HA is that the viewership doesn't match the population distribution. So not too bad. So let's just translate that into the chart how we did before and kind of call into question the expected frequency, which will be the trickiest part. So we have our observed frequency is just what was given to us. It's what we observed when we did this sample. So we have 250 people from the north watched it, 300 people from the south, so on. And so overall, when you add those up, 1,000, or again, these are in thousands, so it looks like 1 million people watch the show. We'll just say it's in thousands from this point. So 1,000 people watch the show, let's say. And now we have to come up with our expected frequencies. Well, really the expected frequencies are going to be what the numbers would be if our hypothesis was true, if the viewership did match the population distribution. So let's say that let's just pretend there's 1,000 people in the US. So like the number of people that we sampled was everyone in the US. And 26.1% of people in the US live in the north. Well, 26.1% of everyone in the US, kind of pretending that there's only 1,000 people, would mean that 261 people live in the north. And thus, if there were 1,000 people who watched the show, I would expect that 261 of them watched the show. So you can see, because we have, it's not like even across the board like the last problem where we had, are they equally likely or not? So it's just 25 all the way down. In this case, we're kind of matching it to something else. So I did 26.1% times the 1,000 people gives us 261. If 32% of people live in the south, then I would expect that 320 of these 1,000 people tune in for the show from the south. So just applying the population distribution percentage to the overall number of people we sampled. And you just do that for every single one. 13.9% times 1,000 is 139. 28% times 1,000 is 280. So there are all of our expected frequencies. So just kind of keep that in mind. There is a difference solely based on kind of the context of the problem, what it is we're wondering about at a core level, and you just tie what it is we're wondering about to the expected frequency. Everything else is plug and play. So let's do that part now. So at this point, I'm just going to plug into my chi-squared formula. So I need to do my OF minus EF portion, so that portion of the numerator. So I just do that. I'd say 250 minus 261 is negative 11. I do that for every single one, 300 minus 320, all the way down until I get a value of OF minus EF for each of those values. And you should see, again, that this should check out to equal 0 right here. That's your check digit to make sure you're doing everything correctly up to this point. So at that point, you have your numerator, but you just need to square it. So each of those values, square them. So negative 11 squared is 121, negative 20 squared is 400, and do it for every single one. Now, to kind of differ from the last problem, because you can see we have different EFs for every single observation, for north, south, east, and west. Whereas for the last one, the different brands that we were looking at were even across the board. We can't do that shortcut where we just add up all of these OF minus EF squares and then divide by a common denominator, because we don't have a common denominator here. So we're going to do the first method that we saw in the last problem, which is exactly this right here. So just take every single OF minus EF squared, divide by its respective EF. So you see 121 divided by 261, 400 divided by 320. You do that for each of them, add them all together, and that's going to give you your overall value right there, and that's how you find your chi-squared. So again, I think the trickiest part about all of this is how to find that EF. Just try and do your best to wrap your head around the context of the problem, find out what it is they're wondering about. Keep in mind that if you're taking a sample, in this case we're saying 1,000 people, just think, what would you expect for the number of people to fall into each of those regions be? Well, if we're wondering if it matches the population distribution, make this group of 1,000 people match the population distribution, and that's what we would expect to happen. For the previous one, if we had however many people was, 100 people, we asked, did they have a preference between the brands? Well, if there are 4 different brands and we're wondering, is it equally likely that they select any of them, evenly divide that 100 people between the 4 brands, and that gives you your expected frequency. Everything else is really just understanding what this formula is, how to plug into it, but I hope that gives you 2 solid examples to sort of wrap your head around, give you good examples to think of whenever you're working through future problems. So thank you so much for watching, and I hope that helped.